Hello, welcome to this video. We'll be going through the USACO 2016 December contest, bronze problem 1, square pasture. You can go ahead and take a quick read through of this problem. Okay, so let's quickly discuss what we're given and what we need to find. So what we're given is, as input, 2 lines, each one containing a integer, each of them containing an integer, and each of them represent a point x1, y1, x2, y2, which are the lower left coordinate of the pasture and the upper right coordinate of the pasture. And what we're trying to find is the minimum area required for a square pasture. So we have these 2 rectangular pastures, so 2 rectangular fence pastures, and we're trying to find what is the smallest, smallest pasture that is square, such that it can still be that it can contain both of those rectangles. In this case, we're looking here. That is 6, 6, 8. So, and then that, like, given this sample input, we're given the output 49. Let's maybe take a look at how this is actually being done. So, in this case, we can visualize this as 2 rectangular pastures. So you can make any type of pasture you want. I'll do something like that. And we're trying to find a square. Let me see. Is there an easy way to? Yeah. So we're trying to find a square such that maybe I start here, and I can do something like that. Would that be the minimum? Well, maybe not. There might be a way to maybe make it so that it is like this, or maybe, yeah, I think that's actually the minimum. It seems like it to be. Yeah. And you can see like why that's the minimum. So you don't have to actually make it so that it's exactly inside, like, or rather, have everything exactly like in certain position. We don't care about the positioning. We just care about the length of this value. So, oops, length. Maybe we have another pasture that looks something like more like this. So we have that, and then one long one right here. So given something like this, then the one we might get might look something like this. Yeah, maybe something like that. And so yeah, the positioning, of course, doesn't matter. We just care about the length of the square. So what would be one solution for finding this? Well, let's take a look at the Python code and find out. Okay, so for the solution here, what we're trying to do is, first I read in the rectangles right here. So those are the rectangles part. In here, we just convert them from like the string version to the integer version. This is the right file, and the solution here, what we do is first decompose it into R1 and R2, which are the rectangles. And what the way I would want to solve this is, we know that somehow it must be a square, so it doesn't matter if it's the side that's the top and bottom part, which is the height, or the bottom or the base part, which is the right and left. So one of those two must be the square side. And we're trying to find the maximum of those two. So between the two there, we're trying to find the maximum between top and bottom and right and left. The reason why is if top and bottom is larger than right and left, then that means the right and left can be placed inside. So you can kind of think of it as sliding along, as I did from before in here. So you can think of it as sliding this, sliding this around until you get to the appropriate like size. So for example, maybe you had something like this, you can just slide it in like that. Or if you had something like this, you can slide, basically if it's something like that, you could do sliding it up and it'll eventually fit. And then same if right left is bigger than top bottom. Now, to find that, basically left is defined as the minimum between the left point, or the first, so in this case, x1, the minimum value of x1 for rectangle 1 and rectangle 2. Bottom is the minimum of rectangle 1 and rectangle two's second point, which is y1. Right is the highest x value, so that is for r1 and r2, the second value. And top is the highest, should be the highest r1 and r2's fourth value, which is the y2. And after we finish that, we don't exactly send the square side. We actually have to square it because in here it says to output the minimum area required of the square pasture. So we're not getting this, we're not outputting the side, we're actually outputting this area. So the area of a square is just the side squared, basically, or the side length squared. Okay, thank you for watching, and have a nice day.